Okay. While we kind of pull ourselves together, you did not have to do these. Can you do them now based on what we talked about yesterday? I think some of them might be tricky. But based on what we talked about yesterday, using page 14 of your reference table, this electromagnetic spectrum, label these. Which one of those, what is there, 2, 4, 6, 7 parts of the electromagnetic spectrum is the heat wave? Go through and do those, if you can remember. There's not anything we put into notes or anything like that. So if you can't do one of them, you don't remember one of them, I bet you know a few of them at least. I like that a few of you look like you actually labeled on our reference table, which we're gonna do in a minute here anyway, if you didn't yesterday. So let's start this off. We did talk about it yesterday because I saw it on some people's reference tables. Which one of these are the heat waves? That's the infrared. Oh boy. If you do not have that labeled on your reference table, maybe give it a quick label. I'm just labeling it heat. If you didn't know that right off the bat without thinking, go ahead and label that on your reference table, heat. All right, how about the next one? Lead best protects you at the dentist. Holy cow, words are difficult. Those are x-rays. They are on your reference table, but I think we all know what an x-ray is, okay? The sun is literally sending those same waves that take pictures of your bones to Earth right now. Anybody see their bones? Yeah. You do see your bones? Oh, okay, so we talked about it yesterday. The atmosphere weeds those ones out and doesn't let that wavelength in. So we're safe. We don't have to look at our bones because of the atmosphere. Skin cancer is the result of too much exposure to? Which ones? Yeah, that's the UV. You could call it UV, or if you want to spell it out, ultraviolet. In our reference table, again, unless you knew that one without thinking too hard, we're going to label that one sunburn. Okay, so it sounds like some people did. I saw blank reference tables and filled in blank or reference tables. So not gonna, it's a good idea to label it. Music essential on these. Yep, radio. That's supposed to be like a joke or something? No, for real. The sun is sending out radio waves and we basically hijack them. And you know how on your radio you got to turn in and like there's like 97.2 or 97.8. Those I believe are different frequencies, and we kind of match up with what the sun's already sending out. Okay, but if you tried to listen to 98.7, it won't tune into the right one because those are slightly different frequencies and you can't hear them then. Okay, it's not a lie. Nuclear bombs, deadly rays are gamma. And good old gamma, they are the nuclear. Again, if you didn't label that, highly recommend labeling it. And how about this one? This should be most of the waves received, most of the waves sent by the sun received by the earth. Which ones are the most that get to earth? Guys, are you cooked? You are, like a piece of chicken? And not even the good kind of cooked chicken. Like you put a piece of chicken, raw chicken in the microwave and hit go for 6 minutes. Yeah, it would turn out to the most nastiest, yuckiest chicken you've ever eaten. Are you cooked like that?
You put chicken in the microwave?
That's what I'm saying. You probably don't want to cook chicken in the microwave. You could, you can eat it. I'm kind of gagging thinking about it. It would be cooked.
6 minutes?
In the a one piece of chicken, it would probably be cooked. It'd probably be just, I'm gagging, like literally thinking about eating chicken. Yeah, I mean, maybe it wouldn't be all the way cooked. Okay, let's put it in for 20 minutes. Either way, I don't want to eat chicken cooked in the microwave. Not the point of the story. Are you raw or are you cooked right now?
I'm cooked, yeah.
You're not cooked.
I'm raw.
You are raw right now. Raw because no microwaves make it through the atmosphere. Yeah, there again, somebody was telling me, well, what about UV? I get cooked with those. No, you just get like changed a little with those. UV does not cook you either. It could sunburn your skin, but it's different than cooked. Anyway, which one then, out of all of these, do we get the most of, you think? No? No?
Microwaves.
No, we already said no to that one.
Radio waves.
No?
X-rays.
No.
Visible.
Visible light.
Sure, I just said that.
I know, but I was kind of going with Carter, who was being loud and obnoxious.
Well, I was there.
We'll just let them know when it's fine.
Visible light. Guys, okay, so yeah, it's kind of gray out today, but the fact that there is any light or any color are visible light. Most of what we receive from the sun is actual visible light. So again, the sun sends out all of these guys, but luckily for us, most of the bad ones at least get filtered out. And even the sunburn ones, the UV, most of them get filtered out by the ozone layer. If they didn't, we would all most likely have mutated, and skin cancer would have changed how we look and act. Yeah.
Why didn't astronauts die?
Oh, they don't go out naked, do they? No. Astronauts wear their spacesuits, which are very, very high tech, so that the UV cannot get to them. If they went out naked, they'd be in trouble. I don't think they've tried it, no.
They always knew that.
Yeah, they knew that. Yeah, if they knew enough to go to space, they knew enough that they had to wear a spacesuit. Takes a lot of knowledge to get to space. They didn't just go. Okay, don't. You need to wear a spacesuit.
Sarah and Kaden's right here, that's great.
All right, let's keep going. Your homework was again using this reference table right off the bat. Scientists are concerned about the decrease in ozone in the atmosphere, primarily because ozone protects life on Earth by absorbing which wavelength? Yep, I see a bunch of number ones, ultraviolet. Guys, we only briefly talked about that the other day, but that is something you kind of just got to know, that the ozone protects us from the sunburn ones, which are UV rays. Oh, this one's right off the reference table though. Which part of the sun spectrum has the shortest wavelength? Two gamma. I see it. Nice job, guys. So again, as we go to the left, so again, in case you get confused with your left and right, look at this L. As we go to the left, they get smaller. And speaking of, so that's gamma. The next question is, which one has the longest? Yes. As we go to the right, they get longer, and radio waves are the longest. I do want to point out, and I'm not sure I have spent enough time talking about this yesterday. See how visible light's listed down here? Visible light really fits in between, right between ultraviolet and infrared. So this little section here is visible light. But then, do you notice how they list all the colors down here?
Yeah.
They didn't just randomly put the colors. Those do the same thing. So visible light this way gets smaller. Why don't we add this label? Smaller this way. So decreasing wavelengths, and again, they get bigger as we go to the right. So they behave the same way. They just didn't have enough room to squeeze them all in up at the top there. All right, question 4. This one was weird, and this is kind of what I was talking about the other day with reading messy looking graphs. As long as you read, I think you probably could figure it out, but if you just jumped right into the question without trying to figure out what this graph was, you would have been lost. It does tell you, it shows the types of electromagnetic energy given off by the sun. The shaded part of the diagram shows the approximate amount of each type reaching Earth's surface. Which conclusion can best be supported by the diagram? So before we even get to the questions, I want to make sure you understand the picture. How much gamma rays make it based on the picture?
0.
0. How do you know that? Because there's no shading. How about X-rays? 0, no shading. Same with radio waves. How much ultraviolet makes it? A teeny tiny bit. I don't know how much, maybe 10, maybe 5. But moral of the story, very tiny bit. Same with infrared, a little bit more than ultraviolet, but still teeny tiny. What do you see in visible light? Lots. Okay, probably close to 50%, if not a little bit more. So going through, process of elimination are all types.
That's not it.
No, because we see none there, none there, and none there. Are gamma rays and X-rays the greatest amount? Nope, still none. Visible light makes up the greatest amount.
Yeah.
More than likely, but guys, just double check the last one too. Infrared, ultraviolet and infrared make up the greatest amount. Nope, they have some, but definitely not the greatest amount. Answer 3. And finally then, what is the basic difference between ultraviolet, visible, and infrared? Looking at this, ultraviolet, visible, and infrared. What's different about them? Yep, I'm seeing lots of those fingers. They're wavelength. And you did not have to answer question 6. Honestly, I would have to get an old reference table out because they actually, what they used to do is instead of just saying smaller to the left, bigger to the right, they used to actually have numbers with the wavelength. And as you can tell with those numbers, 5 times 10 to the -5 centimeters, it would have been it wouldn't be straightforward. We would have had to do some scientific notation. For once, the regions actually made your lives easier by changing the reference table. Yeah, you wouldn't, I can't even do it. It's something I would need a reference table for. Then we're gonna move on then. Yes, no, I don't remember what day. Earlier this week, we went through and talked about insolation. Do you remember what insolation is? Yeah, you do. The pink stuff, right, in your attic? No, thanks for listening. It's not the pink stuff in your attic. Insolation, not insolation. What is insolation? Solar energy reaching Earth. So insolation is the energy that is reaching Earth from the sun. Solar energy from the sun. We talked about that there were some things that control how much energy we receive from the sun. There were 3 of them. Do you remember any of them? No, that's how heat gets moved. Good. I'm talking about a couple days before that when we talked about just the insolation and what controls if we get a lot of energy from the sun or a little bit of energy from the sun. I like it. Some people don't remember, so we're flipping back in our notes. Novel concept, people.
The angle.
The angle of insolation is one of the things that controls how much energy we receive from the sun. And guys, when I'm talking about how much energy we receive from the sun, imagine we had solar panels out. What would control if we got a lot of energy on those solar panels or a little bit? And the angle is one of them. So if the sun is high in the sky, we're getting more energy on our solar panels. If the sun is low in the sky, we get a little bit of energy from our solar panels. What was another one, remember?
Duration of insulation.
Duration of insolation, so how long the sun is out. If the sun is out for a long time, our solar panels get more energy. If they're out for only a little bit of time, then we don't get a lot of energy. And anybody else remember the atmosphere transparency? Basically, whether it's cloudy or sunny. If it's cloudy, not a lot of energy at those solar panels. If it's bright and sunny, we get lots more energy. So it's good that you remember all three of those. Now we're going to go into some details about each one of those three things. So we're going to start with angle of insolation here on the board. I'm going to go ahead and do the PowerPoint so you can see better. So we're going to talk about angle of insolation first. If I can get all this stuff out of the way, what's going on. I don't want to, what? Whoa. Maybe that'll go away. Go.
You hide it,
More. Hide. Not what I wanted to hide. Hide. No. What? Why am I having trouble? I've never had, there we go. All right, angle of insolation, which we already talked about a couple days ago. We're reiterating it, we're saying it again. So the fact that I'm having you guys write this again, what do you think that means?
Important.
It's important. We are on, if you can't tell, we're on page 11, the bottom of page 11. So when we say altitude, do you guys remember again what altitude means?
Like,
Yeah. Yes, it's the height above the horizon. So how high it is in the sky. We did talk about altitude of Polaris way back in chapter 2. If you remember, the altitude of Polaris equals your latitude. We measure it in degrees. We're going to measure the angle of the sun in degrees as well. When I say degrees, I'm not talking about Celsius and Fahrenheit. I'm talking about degrees like angle. And I know when we bring up math subjects, a lot of you get a little nervous. But we're not ever going to get out a protractor or anything like that. I am going to tell you, you'll have to know a few basic angles. For example, do you guys know what a 90-degree angle looks like?
yeah, right.
It's a right angle, so that's the perfect square. If the sun was directly overhead, do you guys know where that is? Directly overhead? Straight up. Now notice when I'm pointing straight up, my body makes a 90-degree angle with the ground. So that's where we're talking about the angles. It's where the sun is compared to the ground. So if the sun is here and you're here, That's a 90-degree angle with your head, for example.
Oh,
Okay.
excellent.
Shut up, Zach. I mean, thanks for your constructive criticism, Zach.
Exactly.
Okay, 90-degree angle. I need you to know 90 degrees. What's the angle if the sun was over here? That's a 0-degree angle because it's not above 90, or it's not above the ground at all. And then do you guys know what the angle would be? 40, no, I don't even know that answer. I just want a number. About what is that one? Not perfect, but it's supposed to be a 45-degree angle, halfway between 0 and 90. Then the only other thing you'd have to know is if it was here, it's less than 45. If it's up here, it's greater than 45. So we're not looking for doing real algebra math with all those things, or not algebra, geometry math. Okay, so as long as we remember the elementary stuff, we're good. So speaking of, here's some pictures. This is supposed to be a flashlight. Not sure. So I'm not sure you're buying it, that it's a flashlight, but let's pretend it's a flashlight. And this is the table. We got a flashlight and a table. What angle is the flashlight ray is making with the table?
90.
90, good. So you really do know the angle. I'm gonna add that label. So I have a 90-degree label. Again, you can see right here. That's the 90-degree angle. And if the flashlight was shining directly overhead the table like this, what does the light look like here underneath it? Right. Hey, you guys got your phones on you?
Yeah.
Okay, you got flashlights on your phone?
Yeah, of course.
Okay, let's do this. I want to show you how bright. Shine your flashlight straight down at your table. So it's straight down. What do you notice about the light underneath your flashlight? Okay, I hold the flashlight in your hand, shine it over the table. What do you notice about the sunlight?
I can't see it.
It wasn't funny when Carter did it. It's not funny when you do it too. When you shine your flashlight, let's do it for real. What do you notice about the light underneath your flashlight?
Smaller.
It's a small area, but it's a small area, but what do you notice about the light? It is a circle in this small area. Okay, let's maybe do it opposite this. Now take your flashlight and hold it at a 45-degree angle towards the 45, like tilt it, just got it. Tilt it sideways. Now what do we notice?
Can't see.
Still not funny.
Oh, it's a smaller light.
Is it a smaller area?
Yeah.
No, it should be bigger,
It's a bigger area.
but,
Intensity wise.
okay, thanks, Mr. D.
Which one's more intense? When it was.
Less bright when it's sideways, more bright when you're directly overhead. Whew. That was a struggle. Let's put that away. If I'm not gonna be able to handle the standards change at all. All right, anyway. This is the notes I want you to put. I know it's little and red, so if you're having trouble seeing it, here's what it says. It says the light is most concentrated. So you should have noticed when your flashlight was straight overhead that the light was brighter. Yes, it was in a smaller area, but it was brighter. If that was the sun, it would also be hotter. So the higher the sun in the sky, the brighter and the hotter it will be.
That's facts.
So you should be writing these exact notes. You should have the 90 labeled and these 3 lines here underneath. So it says light is most concentrated, heat is most concentrated. Part of the reasons we have warmer temperatures when the sun is higher in the sky. Did somebody shake the snow globe outside?
Yes, I did. Oh my God, that's how it Valley was right there. Oh my God.
That's right.
Easy jump.
Interesting.
We're not going outside. No.
Go
okay.
skiing.
All right, here we go. What's this?
Five.
Okay, so again, hopefully you're able to establish that this is about halfway between 0 and 90. So this is a 45-degree angle. And just like we talked about, now the light's more spread out. It's covering a bigger area. Same amount of light, bigger area means it's more spread out, less concentrated, which means we have less
Why you put a present?
and cooler temperatures. I don't know. Here, you want me to end them? There, does that make you feel better?
Yes.
Okay, good. Glad I could make you feel better. That helped, Destiny.
What about that later?
I just said we're not going outside.
Go skiing.
You can when you get home.
Should we go skiing?
We cannot go skiing.
Like at the class.
Oh, no way, not.
What?
Do you need a list?
Yeah.
Zach,
Yeah.
Carter, Jack,
Why? I don't even go to Howard, really. I just want to go skiing.
the rest of you didn't make the list, sorry.
That Carter and Chaplin.
Are the reasons we're not going skiing.
Well, so say we kick Zach and Jeff out, right? Can we go skiing?
No,
You're
we
still
cannot.
on the ground, say, well,
All right. No, I'm just kidding. I'd gladly meet any of you out skiing, but I'm not taking you guys anywhere.
Well, what if we bring in money and we pay for it?
I'll meet you there.
I am your line.
I'll meet you at KB. Well, I got that, but that's where I go, so I'm not going to Holiday. It's an hour from my house. Okay, but it's not an hour from my house. All right. We got this angle stuff. You get it when it's higher in the sky, we get the brighter circles and it's hotter. When it's lower in the sky, it's not as bright, not as strong. So how about this? Hopefully you know the sun's not always at the same spot in the sky. Hopefully you knew that, right?
It moves.
It appears to move. So here's my question to you.
When I'm in a car.
Be quiet. Here's my question to you. Why or what makes the sun be at different spots in the sky? There's at least 3 things that control where or why the sun is where it is. Jeff, you got one?
Rotate.
Okay, so you don't get so technical.
The day of the month.
But what the rotating causes what? Because, okay, you pretty much got it. I want you to actually think less. I know. Has anyone ever told you that before? My question is, you know the sun's in different spots, right? Or can be in different spots? There are 3 things that make the sun be in different spots in the sky, that is.
Time of the day.
Time of the day, which is the earth rotating, Jeff. So you weren't wrong. The earth spinning causes different times of the day, and the sun will be in different spots depending on the time of day. Please tell me you guys knew that part, right? Where is the sun in the morning?
Down.
Down by the ground. Where is the sun in the afternoon? Up in the sky. Where is the sun in the evening? Down again. Okay, so I hope you knew that. That part's not news to you. You guys have not lived under a rock for the last 15 years.
Correct.
You knew that? Okay.
And
So time of day controls where the sun is. That's one thing.
day of the year.
Day of the year. What do you know about different days of the year, Carter?
There's less sunshine in the winter than there is.
Now- What'd you say?
There's less sunshine in the winter than there is.
Are we talking about sun time though?
That's not quite what
The solstice.
Okay, you're not wrong. It is time of, would you say day of the year? Is that what you said? Different days of the year have different angles of insolation as well. This one you might not have noticed. Not because you've lived under a rock, just because you might not have ever thought about it. In the winter, the sun is lower in the sky than in the summer. Why? It has to do with the tilt, and it's technically next chapter, but I can show you kind of right here. I'm not gonna do the whole presentation with this thing, but here's what the earth looks like in December, the earth and the sun. So if you can't see right now, so again, this is what it looks like in the winter. See how the earth is tilted away?
Yeah.
So when the sunlight shoots out of the sun, it's gonna hit right here, which because of the tilt, is hitting down underneath or south of the equator. So for us up here, we're getting a very low angle of sunlight. Versus here, I'm gonna change it. This is not quite how the world works, but I'm gonna change it. Here's summer. Now, notice how the earth is tilted towards the sun.
Yes, we get more sun.
So now that, not more, it's a higher angle. So now it's hitting right here in the northern hemisphere. Here's what it looks like pretty much now, almost the first day of spring. If you notice, it hits right on the equator. So a little bit between the two. This whole thing, by the way, is next chapter. So if you didn't catch what I did here, really all you have to remember for this chapter is that in the summer, the sun is higher in the sky. In the winter, it's lower in the sky. So we've already established that time of day, time of the year, and there's one more thing that controls how high the sun gets in the sky. Can you think of something else that will change where the sun is in the sky for the person looking at the sun? No, it doesn't matter that it's cloudy out. If it was sunny, the sun would be in the same spot. Where the person is, their location. So whether they're at the North Pole or the equator or the South Pole makes a big difference. So we are running out of time, but I do want to get as many of these notes in as possible. So if you switch over to page 12, we're now just going to write notes on all of the things that you guys just told me. Was any of that stuff I just told you news to you? Time of day controls where the sun is? Okay, so let's start with the very first one at the top of the page. See where it says number 1? Number 1 is time of day. So put where it says number 1 goes time of day. And then underneath that, there's a spot that says sunrise, solar noon, and sunset. So for sunrise, sun is low in the sky, cooler temperature. Solar noon, sun is highest in the sky, warmer temperature. Sunset, low in the sky, cooler temperature. I don't think any of that is new science to you. Yeah, you never, ever know what's going on in Joe's class.
Well, is that what you thought last year?
That's what I thought every day I have been next to Mr. Jones for the last, 8 years.
I was rowdy last year, Mr. Joe. Teach you out there.
That doesn't help anything.
Pretty sure it's possible. Actually, it's not possible.
Foolery going on in there, you're probably right.
Yeah, but crazy part is, with all that tomfoolery, we're
Tomfoolery.
having fun, he's teaching us the stuff.
Yeah, he's real good at that. I'm not as good as that. All right, everybody got this part?
So basically,
So basically, the other thing that controls how much or where the sun is in the sky is your latitude. Again, there's a bunch of lines to the right of the word latitude. So number 2 this time is latitude. These are the only words that need to go on those lines. There are way more lines than words. So the lower the latitude, the higher the angle of insolation. Which really means at the equator, which has a latitude of 0, the sun is high all year long. That's why near the equator, it's warmer. At the poles, which are 90 degrees, the altitude of the sun is always lower. Which again, lower sun means cooler temperature.
that out. Are you not supposed to do it? Yeah, but-
And the last thing we're gonna do, if you are ready to go there, number 3 is going to be season. Or time of year like Carter said.
Unfortunately, we're running out of time.
We have just, I think we have time, it's a very small bullet if I remember correctly. But I think you'll have just the perfect amount of time. There is no homework tonight. Enjoy your weekend. Go skiing at the fancy place, unlike what we'll be doing. Yep, nope, just KB for us. Thanks.
How many Valley students go to, I will say, HB?
Guess what? KB's a lot cheaper, peeps. All right, ready?
Yeah, that's an hour drive.
Season. In the northern hemisphere, the sun is highest in the sky in June, which is why we have warmer temperatures. And that's our summer. The sun is lowest in the sky in December. And that's why we have cooler temperatures and our winters. Also, thinking about solar energy. It was sunny yesterday. How come barely anybody got sunburned yesterday?
There's no sun.
No, it was sunny yesterday.
Because it was cold out. Cold.
No, that's not why.
All went outside because it was cold.
Oh, because they didn't go outside because it was cold. Okay, I'll buy that. But if you were outside, how come you didn't get sunburned yesterday?
Angle.
Because the angle of insolation, if the sun is low in the sky, we're not gonna be getting a lot of sun. It was sunny when I was out boiling my maple syrup. It was sunny.
You were what?
Boiling maple sap to make maple syrup.
What name?
Got a gallon and a pint of syrup yesterday.
I'm still.
It's my expensive pastime.
You have a lab to do Monday?
Yeah, well, I'm not actually sure if we're gonna start one on Monday.
How many more days a week? I mean, it's. Oh, God.